So we'll do two last problems, and we're just going to find inverses this time. So I'm going to change it to y equals, and then just solve. So we're going to go ahead and divide by 3. That was weird too. Then you're going to square both sides. Y over 3 squared equals x plus 2. So I squared both sides. Y over 3 squared is just y squared over 9. And then subtract 2, so x is going to equal y squared over 9 minus 2. So I'll write that in inverse notation. Now, technically, I just want to make sure we're aware of this. Technically, we would have to state a domain restriction in this problem because it started out with a square root. So we actually only have half of the quadratic in the end, and if these are truly inverses. Because this is a positive square root, I know that my restriction should be that, and we're doing y as our input, so y has to be greater than or equal to, and we just got to figure out what that value is. And that value is always just going to be the horizontal shift. There are no horizontal shifts in this, so it's just going to be y is greater than or equal to 0. Another way you can figure that out is if you know what the graph of 3 times the square root of x plus 2 looks like. So that just means we're shifting over left 2. And then there's a vertical stretch of 3, which isn't going to affect anything. Notice that graph is above the x-axis, so y is greater than or equal to 0. So that's just technically a stipulation that I just want you to be aware of. I'm not going to test you on that, though. So let's do one more. We're going to find the inverse of this one. So notice we have a domain restriction. That's because even though this isn't quadratic, there's a quadratic-like part of this equation, this function. So that's going to be important. So we're going to go ahead and solve this. You can solve it that fast way I talked about earlier. In fact, there's actually where you multiply by the denominator. There's actually a quick little way where you just swap these two. Because if you're multiplying by x minus 2 squared and then dividing by y all in the same step, you'll get x minus 2 squared equals 1 over y. So I'm going to show you on the side. So I multiplied by x minus 2 squared, so you get x minus 2 squared y equals 1, and then you, in the next step, divide by y. So some people just do that quick shortcut. From there, remember we're solving for x, so we're taking the square root. Remember, square roots have positive and negative answers, and the one we pick is all dependent on the domain restriction, which in this case, it's greater than 2, meaning it's going to be the right side or the positive values. So we're going to go ahead and say x minus 2 is equal to positive square root of 1 over y. I can add 2, and I can say x is equal to positive square root of 1 over y plus 2. Which really, they usually like the 2 to be in front. The reason for that being so people know that the 2 is not under the square root. And we're not going to rationalize this. That's totally fine. We're just going to leave it as is. There you go.